So I have a couple of different things that I want to get to today. We would like your feedback. There's a bunch of things that we're trying to do in this class, also things that we've changed from past semesters, like focusing more on agents, focusing more on risks, security, hazards analysis. Making labs required, we didn't always used to do that. Doing debriefings also for individual assignments, to kind of make sure that you actually understand what your agent generated for you, right? So this kind of thing. And breakout interactions in class, things like this. So if you have any opinions on this, I think there should be a link on Slack now. I would appreciate if you could fill out that form. It's anonymous. It would help us to change the class going forward, right? If you hated something or think we should continue doing this. Then I want to briefly talk about I4. I wanted to see, now that you generated explanations yourself, what was hard? Or was it super easy? Was it obvious what your users wanted to know? Did the personas help? Yep.
One issue was like when I was preparing talks for like community health workers or like volunteers to it, I wasn't sure like what kind of images should I even add from an explainability point of view, and would they be able to like understand that, given that it's a key area for volunteers because they don't necessarily have too much medical information.
Right. How much do your volunteers know, right? How much training do you do too? You can probably train them quite a bit. I think your volunteers, you could probably get to read Shapley plots if you have some training, right? They're probably doing this more than once. But do you want to do that? Any other concerns, thoughts, surprises?
Just in addition to that, it's not that easy for community health workers. It depends on the setting. So I work with community health workers in India, and they absolutely have like not enough time to train or do additional tasks because they don't get compensation.
I suspect you can do some training up front, but then when they're working in their role, right, they're probably overworked and they have so many patients. So you probably don't want very long explanations. So the commercial products don't really like to share details. One of my collaborators was actually at a diabetics conference and tested some of these products. And then when she tried to tell them, well, but your diagnosis is wrong. I actually have diabetic retinopathy. Why is this wrong? They were very nervous and didn't want to continue talking to her. I mean, she lied. She didn't actually have diabetic retinopathy. These were salespeople at the conference, not necessarily the producers, right? But they are not necessarily prepared to answer those questions. There's not much public information, but I can show you a couple of things. This is for one of the products out there. This is the only thing that you really see on their website as an explanation. It's like clinical results of their studies, sensitivity and specificity for their different devices. This is a screenshot of what they would show to a user. Again, they don't usually share those. This is one of the few screenshots that are public. And the only thing that you could see here is sufficient image quality. Maybe that's an explanation, but otherwise they don't really explain anything. They don't highlight pixels. They only have a result here saying this is negative or not. And so the current products don't really include a lot of explanations for anybody. We talk to developers who are actually in some of these contexts for developing countries, developing some of these products. They don't have explainability experts, right? This is the developers themselves that need to make those decisions, similar to you, without a lot of training in that space. Maybe if you have a really big company, you're working at Philips or something like this, they may have some HCI explainability experts, but I think in most organizations, it's the developers like you who are gonna do some of those explanations, maybe with a little bit more domain knowledge than you, but still not necessarily really with a lot of background of different explanations. When we talk to doctors about what explanation, like, I always forget the English terms. In German it's easy. It's an eye doctor or it's a foot doctor. This is like really easy. So the eye doctor people, when we talk to them, they were always of the opinion, don't tell patients any details. Less is more. So I think in that context, if you highlighted any pixels, produced any Shapley plots, anchors, or something like this, I think this is way more information than what the practitioners would recommend. You could have solved the thing with with like 2 sentences, if you wanted and justified this, saying we detected this because your answer is similar to other images like this. You should see a doctor, or here are the next steps. Right, so I think what you probably found is that patients probably care more about next steps than really which pixels are relevant. But I think a big point here is less is more, and that's probably not intuitive to us. If you're worried now about grading, we're not really worried about this in grading, right? We don't take off points if you highlight pixels or something like this. But I think it's worth thinking about that your intuition is probably not right. And what we've seen in the past, when we started looking at personas, solutions in this class actually got much better. So looking at personas, I can just explain to you what we have seen in past semesters, right? Forcing you to think about the user's perspective actually helps to make the solutions better, also in a way that doctors approve of and non-experts. We also ran this by sociology students. They always wanted more explanations too, right? They think of how is this embedded in society. They didn't have the same intuition as either you or the doctors either. And apparently the manufacturers also get away without really providing any explanation. You have any questions or comments in this space? Thoughts?
I was thinking that if we, let's say, highlight a particular portion, like which was used by the model to, let's say, make that prediction, and if the user feels that the model is incorrect, they can take that to the doctor, and the doctor can see, okay, the model highlighted this part, and this part is not really relevant, and then it could help in maybe overriding the model's decision, or maybe making sure that the model is incorrect or doesn't have something.
So a doctor might benefit from highlighting things, right? I think the patient probably doesn't have a good understanding of where to look in the eye. A nurse or a volunteer, it really depends on how much training you can provide, how much they know about the disease, for example, right? How much of a specialist they are. And I think in a lot of these settings, they're not really, right? They're a people person, they can interact with them, but they probably don't have a massive medical background. I think one thing that we cared about is, and this was an experiment to a degree. We've been looking at solutions for a couple of semesters now. We are interested in how do you get developers to provide better explanations without massive amounts of training, right? Because real developers usually don't have that much training. One thing that we wanted to see is giving you a law or a policy actually useful? What we learned in the past is that just giving you that policy without any kind of forcing you to think about explanation needs leads to disastrously bad solutions. So kind of check the box compliance. You follow kind of the policy step by step with kind of vague justifications, but the explanations are usually inscrutable, really bad is what we've seen. Last semesters when we introduced personas and so on, it got much better. Last semesters we didn't give them the policy. So what we kind of want to see, and we won't look at this until the semester is over, it didn't really affect your grading, is whether the policy was actually distracting, right? Or helpful. Like personas plus policy alone was not good. Personas alone was pretty good. Does a policy make any difference? Right? So I suspect it forced you to think about things like limitations a little bit more systematically. That's in there. I think it frustrated you with the 8th grade reading level. How did you decide on 8th grade reading level?
There's free online tools that will let you paste your thing in there and then tell you what it is, and that seemed like a pretty decent way to do it.
And how often did you have to try until it finally told you this is good enough?
First try.
Okay. Did anybody else try one of those tools? Also first try? So that's, I think, my experience, that we're writing naturally in a way to technical language, and I think none of us have an understanding of what 8th grade reading level is, unless you've been teaching middle school or 8th, right? This is actually, so this is not something we made up. Most medical communication, like the package leaflets and so on, are supposed to be written at 8th grade reading level, and there's an established way of measuring this, which is mostly avoid fancy big words. Right, but it's really hard, and in the past this was always the thing that everybody said, this is hard, right, even when checking this. And again, we're not really grading you for whether you're successful at this. I needed to instruct my TAs to be really lenient on this, because if you assess this with a model, it's unreliable and it's often picky, or you used GradCam or anchors or something like this. This is clearly not 8th grade reading level, but and I would agree it's not 8th grade reading level, but it's also, we don't want to be that picky on this. So I think from our perspective, enforcing an end user perspective just by making you go through a process, so some process compliance, has helped in the past from what we've seen. Mandating it by law has led to a very shallow check the box compliance where you go through the motion and maybe you have a little imitation section, but it doesn't really reflect what the user needs to know. This was a much bigger problem that we've seen. I think there's a question of how much is this better if you have a dedicated policy team or responsible AI team in your company that can help you with this, or an HCI team that can help you with this, right? Also, for the record, there were 2 different groups that just differed in the stakeholders. That was pretty minor. One was nurses and patients, and the other one was individual explanations for nurses who oversee this, and then sales reps, essentially, who try to sell this. You're trying to sell this to non-profits, right? One thing we want to see is how much this actually differs in the end. But again, it shouldn't really matter for the assignment too much. Yeah. So I think there is a bit of a discussion, how naive is it that we just post a policy and expect you to be able to do this? And I think in a way it's very naive to kind of just assume, oh, let's just write this into law. Like the text that we gave you was based on partially the blueprint for AI, which was a government document. And there's a lot of people who believe, yeah, if we just provide the right law, right, developers will do what we want. But usually there's a huge step of how getting from the law through some implementation guidelines, through a culture of practice where people actually understand this. And I think we saw this very clearly in past semesters, and I think a little bit more empathy, kind of, or forcing you to have empathy with your users at least helped a lot. Make sense? All right. So I want to look back a little bit at the semester, and I want to do this from the perspective of risk. So I started with risk in the second lecture. We started talking about how models make mistakes, and that's kind of fundamental, right? All models are wrong, some models are useful, so we kind of need to deal with mistakes. But also humans make mistakes, and maybe model mistakes and human mistakes. I mean, they're not exactly the same, but I think we need to build systems that are safe despite these mistakes, right? With humans, we have seen this before, and we think about mitigations to operator errors. We don't expect humans to never make mistakes or to train them until they never make mistakes, right? We prepare for mistakes. And we also know this with the environment. I like this argument. We're not just buying better network cables, right? And all that we're doing in machine learning with training better models, having better benchmarks, is still like buying better network cables, right? We're trying to reduce the distance with mistakes rather than thinking around how we build more reliable systems with So in the end, I think we should be more honest about risk, and that there's residual risk, and that we should think about how to build safe systems or when we can build systems. And this gets to the point that at the end there's probably some mistakes that are unavoidable, even with all our mitigations. Right? There's very narrow places where you can have symbolic guarantees. You played with some of them for agents, but most of the time I think even humans might disagree. And then you get to situations like this, right, where AI makes a mistake. Maybe you had safeguards, but the safeguards didn't catch those mistakes. Here, probably you had a human in the loop. And I guess eventually in this case, a human in the loop approach, because there's a judge in the loop, right? They released this grandma after 6 months. But that's a long time, right? And I think in the end, we cannot really avoid those mistakes fundamentally. And maybe it's good that it's a big news story, because we tell news stories about outliers. If this would happen every day, this wouldn't be a news story, right? This would just be background noise. So at the end, I think we need to think about what residual risk are we willing to accept. And we might very well say, this is a really bad outcome, but we compensate one person affected by this. It's so rare, right, that we rather compensate this, and the benefit of the system is big enough. And I think it's a really uncomfortable place to be in as a designer of a system, but I think it's somewhat realistic, right? I think you will not build a system that never makes mistakes. This is really hard to be in traditional software, right, where everything is symbolic and you could, in theory, prove things. And Claire always shouts at me as software always has bugs, right? Stop pretending that we could have proved this correct, right? But we're still teaching it like this, right? You learned all precondition, post-conditions, loop invariants, or most of you, right? I'm sorry, but I think this is how we're thinking about software most of the time. And I think this was never realistic. And now I think you really need to understand that we need to deal with residual risk, right? And I think we should be honest about this. And from my perspective, what we've done through the semester, a lot of this really ties directly to risk and approaches to understand, mitigate risk. And I want to go through the semester briefly to talk about this and link this back. Right, so we started the first lecture, essentially, we had this Zuno case study, music generation, and asked kind of implicitly, what is good enough? Right? This won't be a perfect system. Maybe it makes some people happy. Maybe there's some risk. We will probably get sued over copyright infringement, right? Can we survive that? I think we need to think about this. And we had this case study, and I'm going to use this as a running example of detecting dangerous objects in suitcases in an airport. Right? Again, we won't get guarantee. It's an imaging problem. Machine learning is a fairly old one. We got much better at this, right? But we should think about, we probably don't know what correctness actually means in the last case, right? And there are some risks. We might not detect certain objects. We might have false alarms. What risks are we willing to accept? What risks can we mitigate? Can we put a human in the loop? We talked about requirements of really trying to understand what do we actually want to do, right? What should the system do? What qualities do we expect? Again, I think this helps to understand why we're doing this. Why are we building this airport system in the first place? What's the goal? What's the outcome, right? What are the qualities that we need? And we started thinking much more seriously about goals and how different people have different goals in the system. They're conflicting goals sometimes, like in the law case study that we talked about. And that we often, honestly, don't need perfection. We just often need something that's good enough. A lot of systems that we're building are not high risk, right? in a lot of cases, we can deal with wrong predictions. But also, risks can be anticipated. And I think this is something that I'm frustrated with, that people often just build something and then say, oops, sorry, this went wrong. This is a completely new solution. Nobody could have seen that coming. And I think that's mostly untrue, right? Yes, there are true black swan events, true things that we could not have anticipated, but most of the things, with a little bit of thinking, you could have anticipated. The harms of social media, right? The harms of algorithmic amplification, of getting things wrong in airport screening, right? I think it's pretty clear what the consequences are. It's just because you were lazy and didn't think through consequences doesn't mean that nobody could have. And I think things like hazard analysis, and I truly believe that probably none of you are going to really do this after this class, but I think it's a technique that's useful and that can help to think a little bit when you're building something up front, that you can anticipate things and potentially do something about it. Right, so I think we can anticipate many potential problems of the airline screening thing and think about, do we put a human in the loop? If we detect something, do we close the airport immediately, right? What's the consequence, or what false positive rate is acceptable, and so on. This makes this a little bit harder to tie towards risk, but we talked about collaboration, right? We played through some teamwork problems. And again, I think my way of thinking about this is there's lots of teamwork problems where you don't even think about risk. Groupthink, we talked about this. I don't know how much this showed up in your team, where you all just agreed. Most of you are still recommending NC-17 movies to minors, right? You clearly never thought about these things. I don't know whether anybody thought about this and was afraid to bring it up to not create more work, right? But I think there's value in this space, and I think a lot of problems really occur from miscommunication between different teams, different backgrounds, and so on. We talked about how accuracy might not be sufficient, how it's actually really hard to measure accuracy. There's many different notions of accuracy, and then we really thought about different ways of measuring quality that's not just average accuracy, right? Slicing, LLM as a judge, or these kind of testing method for specific slicing, or risk from unreliable infrastructure. Can you update regularly? Supporting continuous experimentation. We have to rely a lot on testing in production, right? It's really hard to get ground truths if we don't know what correctness means. Can we build an infrastructure where we can deploy frequently, where we can update things easily, where we can test in production? And that has a lot of monitoring, a lot of measurement. I'm sorry, we did measurement so often, right? But I think it's important to agree on being a little bit explicit about what are we measuring, what are we looking for. I thought the target case study was really fun, of how data quality can really undermine a product. It's another form of risk, right? Not taking data quality seriously, having poor data. And I think, again, you can mitigate a lot of this, but maybe you won't because it's effort, and maybe you didn't think about this. Really scaling, there's risks in that, and ways to mitigate risk. And then MLOps is, again, help to build systems that are reliable, that are scalable, that are where you can experiment, right, where you can update things, where you can react to discovered risks quickly. I think this is a really important skill these days, that you build risky things, you need to be able to take it down or to change things quickly, right? So if something bad happens, like you realize that this thing is systematically not detecting certain things, you want to be able to deploy an update in all airports quickly, right? Or have some visibility of what's happening in your machine in all airports. Versioning, provenance tracking, yeah, good engineering practices. I hope things are getting better. Provenance tracking is not super widely used, but can help a lot with debugging if something happens, right? And security is a mess. Security was always nice if you had clear guarantees and clear properties that you wanted. SQL injections are so nice to teach, right? You have a clear solution, you track how data flows, you have a clear semantic of how to prevent them. We're just losing that with security, with machine learning, and we have so many weird risks through this, right? That developers can undermine the model, can do evasion attacks, can poison the model, and so on. But really, if you're worried about risk, I think thinking about the entire system is the right approach, right? You can't, it's another place where you can't avoid the risk. You have some residual risk. If you have a machine learning model somewhere making critical decisions that can lead to security outcomes, you have remaining mistakes. And you either accept them or you don't build the system, right? I think mostly we accept them and build things where it's not likely that a single wrong prediction leads to a security mistake, right? But if it's really unacceptable, like there's a low chance that you leak all your customer data or somebody can issue a transaction that loses you a lot of money, maybe you really don't want to put a model in that space, right, where a mistake can lead to that. Safety, I think, is very much about risk. I think inherently, right, this is harms that happen from models making mistakes and mitigations across this. I think process can help to mitigate risk, make sure that you think about risk that you do the hazard analysis early, that you keep track of mistakes, that you keep track of mitigations, right? And then I think having some way to understand what's actually in your model, that they're not complete black boxes, again, helps you understand what's going on, what kind of mistakes you're expecting, maybe why, and whether you should trust the model, right? Whether you accept certain remaining risks. End user explanations are hard. We just talked about this and can be manipulative. You can get risks from explaining things to new ones. And then fairness introduces a lot of risks on its own, or has different classes of risks. Again, you can build hard-coded systems that are unfair, and that happens when you're dealing with data in the environment, but you probably wouldn't encode a hard-coded algorithm where you say if race equals something, then reject loan, right? So there's certain kind of mistakes or certain kinds of bias leaking into these systems that are hard, that can happen here much more easily without looking at it. So this was my position in the beginning of the semester, that we know how to build traditional software that's high risk or needs very high reliability. We can build software for nuclear submarines, space missions, and so on, and they don't explode all the time, right? They don't kill people all the time. But working in those domains is expensive, it's slow, it's focusing heavily on process, focusing heavily on hazard analysis and mitigations and so on. And most of us don't want to work in those domains. I always find this kind of scary that CMU students don't really go and work on those domains. They go and work in advertising companies like Meta and Google, right? Rather than on flight control software or nuclear power plant software or something that's really critical. So if the best and brightest don't go work on the really hard software, right, the really risk-prone software, who does, right? It's often people who value this and accept moving slow, right, and careful and doing all the paperwork because they think it's important. But it's not, for most of us, it's not the fun place to be, right? And I think with machine learning, this was my argument in the beginning, right? We're pushing the boundary, we're building more and more risky things. Autonomous vehicles are obviously risky, right? But a lot of these things like airport screening have risk. All these things that we talked about, like photo search can now have bias, right? Seems really trivial, but it's not that trivial. We need to think about mistakes. Social media feeds, right? Sidewalk delivery robots we talked about at some point, how this can create safety hazards. Smart home devices, automated transcriptions, we talked about how a mistake in a medical transcription can have serious consequences, right? So we are building more and more of these systems that are much more ambitious, where mistakes have serious consequences. And my argument is we shouldn't treat this like it's a website without machine learning, like a trivia system, right? And I think we still treat it that way, right? We have a coding agent these days to just let it implement it without thinking about it. And I think a little bit more discipline goes a long way. But I also feel like I'm preaching this and nobody's listening. So maybe some of you will surprise me in the future by telling me that, oh, you actually went out there and changed the world and actually built better products, right? Tell me about it. I'd love to hear that it made some difference.
People don't go to those jobs because of the complexity, or probably it might have to do salary offers, or probably they don't want to hire new grads but experienced people.
So salary offers may have something to do with this. A lot of these things are government adjacent and they don't pay that well, right? So if you can work on ads at Google, they pay so much better, right? But I also think I would expect I would find this very dull, and I think most of you would too, right? If you work on airplane control software, it's not very innovative, right? It's very slow development cycles. It's heavy on the paperwork and validation and making sure that it really works. We interviewed people a while ago, right? It's really slow, it's very high bureaucracy, and the people who are there do this because they really believe this is important what they're doing, even though it's not fun. I think if you're working on something innovative at Google, Meta, whatever, right? This is much more fun. It's a fast-moving team. You're working with new technology. It's very different from a really risk-averse, slow kind of organization where getting your code into a plane might take 10 years.
What do you think should play a role in influencing people to go to those roles? Is it like the competence themselves, or is it the responsibility of each student?
I don't think I have a good answer of how we get more people into those spaces. I think it's not that they have nobody working there, right? And the people who are there do good work. I think what I'm more worried about is that a lot of us are sloppy and are going into fields where we still can do damage, right? We don't have the regulation that they have in aviation to force them to slow down, right? Medical devices, aviation, nuclear power plants, they're heavily regulated, and for a reason, because they're high risk. But I think my argument is that a lot of these systems that we're building right now also have substantial risk, right? But we're not regulating them. So we're treating them like low risk things. And I guess photo search is not as high risk. Like inciting people by comparing them to primates is not the same as a nuclear power plant exploding, right? It's not. It's not the same level, and probably we don't need to regulate it to the same degree. But also this word of let's just build it and then say oops if something bad happens and apologize, right? I don't know that that's necessarily the best strategy as we're building more and more things that can have really bad consequences. Maybe not in killing people, but in destroying democracy, in causing mental health problems, right? In causing massive amounts of unemployment. All right, this turns depressing quickly. So we never really talked about this, but this is how we structured the lecture, right? We talked about the typical phases of building software: requirements, architecture and design, quality assurance, operations, and then all these facets of responsible engineering: provenance, safety, security, fairness, interpretability, transparency. And again, I think you can't look at one of them in isolation. And I know this is kind of broad and we covered lots of things. But I think all of this together is how you think about building systems that are actually responsible, that are actually take risks seriously. So back to this. Would you think this is an acceptable risk? You're selling facial recognition to law enforcement and somebody got jailed over this wrongly?
I do not for us.
So what should we do about this then?
I think have manual review for.
They probably did.
Oh. Well,
I mean, I cannot imagine that somebody got jailed without a human in the loop, right? Just because the model said, like, I might be cynical about a lot of things and about law enforcement probably too, but maybe not to that level, right? We're not automatically jailing people, I think, based just on facial recognition.
How did that happen then?
There was another case, it was in the news, right? There was one in Reno, Vegas, where the casino had a security system with advanced AI, and they had a cop in there. And what was fascinating was the person on the cam said, "Oh, but the system says it's 100%." I was like, "Oh, that's great." Christian said, "This great lesson on explainability," because they literally said, "We thought about doing traditional, detective work, whatever, but it says 100%. So, well, I guess that's what it is." It's like it turned off human in the loop traditional processes.
Right, so you had kind of explanations that were potentially misleading, right, and made the immediate human in the loop part inefficient. In this process, in this case, I don't know whether appeals worked, right, or what the consequences were. Here, appeals worked, but 6 months later, right? I mean, partially this is, you could say a human in the loop worked, right, but is 6 months acceptable? And the way that we're compensating victims of these kind of injustices, like you get a daily rate of $30 or something like this for each day you're spending in jail, probably, right? This is not a way to really compensate somebody, right? And I don't know that this grandmother could now sue the facial recognition company, probably not very successful, right? I mean, the US judicial system does a lot of this through tort law, right? You sue the company and you get quite high fines to kind of get this, but in a lot of cases you have to fight for this, and it's not set up to make it easy to get this compensation, right? And the lawyers take a big cut. So I think you could argue we should never build facial recognition for law enforcement. But you could also argue, what good does it do? And maybe there's lots of criminals that we caught because of this, or lots of crime that we prevented because of this, right? If I was a company building this, I would probably make that case. I would probably say, on average, maybe we shouldn't do facial recognition for law enforcement, right? There's so many problems with this. But I think you can make the argument that the benefits outweigh costs in some case, and you can compensate for costs in some way, and this is the cost of doing business. And if this was a detective without facial recognition, the same kind of mistake could have happened. It probably wouldn't have been in the news, because it happens all the time that somebody wrongly accused goes to jail for a while, right? It's just not because of AI, and this is in the news because it was AI, right? So maybe this is actually better than what we had before. This is really hard for me also, right? I would like to say, ban all of this, right? Don't use it in a law enforcement context. But should we also ban it in casinos, where it's a private company? Should we never do facial recognition? Or anything related, like face login, right, on your phone? Like, where should we stop, right? Should we stop all AI model research out, like bomb, what's the proposal, bomb all data centers that train AI, right? I mean, there are people proposing that essentially, right? That's so dangerous. We shouldn't do any of this. I mean, we just last week, I think, had somebody trying to attempt to murder Sam Altman, right? So there are people who are taking extreme positions there too. And coming back to airport scanning, right? What kind of mistakes do we accept? It actually took me a while to find a real-world example that had seriously harms. I don't think there's lots of stories of weapons getting on a plane because it was missed by security where it should have been. And there's a human in the loop, right? So there's lots of stories where somebody gets falsely stopped at a security checkpoint or the luggage is delayed. But somebody looks into the thing, figures out it's not really a bomb, right? And then you're on your way, maybe you're delayed. This is one of the cases that was maybe slightly bigger, where they had a wrong detection of a bomb, I think, and then shut down the airport automatically. Again, human in the loop, 2-hour delay or something like this, maybe cost of doing business, right? So I think, again, do we need perfection? What are we comfortable with? How much can we foresee and mitigate? Do the mitigations already work? And I think the big systems with law and airport security, they already think in terms of a system, right? They have safeguards in there. They obviously don't rely and put you into jail automatically because the model says so, right? But there are cases where we make decisions easily. So I want you to think about risk more seriously, but I think in the end I can't give you a satisfying answer what exactly to do, right? My appeal is to be more responsible, whatever that means. I want to change topics a little bit. So that was 2017, and I've been making fun of this for a while. I think it's harder to make fun of this these days. This is maybe a more realistic view, or maybe not. Can do the same thing for data scientists, so don't feel safe. Again, this was 2020. What do you think? Is it over? Yep.
I think for like job roles where you're basically designed as like a fall guy, like DevOps, like if there's ever like a situation you need someone to blame, I feel like that's like an appropriate human element.
All right, we need humans to absorb blame. Is this the thing? So we hire people not so much to produce any code, but just to take the blame and get fired if the agent produces bad code. Okay, that's one plausible thing. Oh, sorry.
I don't think so. Software engineers will disappear. I think their roles will just change. What their job contains, that will change.
Okay.
Because we have been trying to automate code writing since the last 50, 60 years. We have been trying to make code writing easier. We have, like, for a lot of high-level languages, compilers write most of the code, but we are writing only a couple of lines. So I think building software would become easier and cheaper, and therefore more software will be made. And maybe writing code won't be the primary job of a software engineer. It will be much more than that.
You still have hope to get a job?
Yeah.
Reported that programmers yelled at him about the invention of compilers in the 60s, about how compilers never write machine code as well as they did, and he was putting them all out of a job. They were wrong on both counts.
Really? I mean, a bunch of people got out of a job probably if they were working as a human compiler.
Human compilers, I do not believe, continue to work as human compilers.
I guess also like there's gonna be more operations, people like fixing downtime, like I don't know if code can like fix it because it's down.
Okay, so our jobs is at 2 a.m. fixing agent mistakes?
One, I think the compiler to analogy is super like almost a category error because compilers are very deterministic and LLMs are the opposite of deterministic. So I don't think that that'll cause the same problems. Yep. But I also think that software engineers are not going to disappear. Last summer I interned at a company that was a very big Salesforce client, and they had like 12 people on staff whose only job was building Salesforce apps in Salesforce. And it's still, they couldn't do it because Salesforce, like, there are these really narrow guardrails to do what you want to do, you can't do it. I think we're going to get to where companies that now have to pay Salesforce or Palantir to like use their fancy big software this will get to a point where you can instead hire a small dev team that can give you your internal tool you want using AI. It'll work better than what Salesforce had. I think that's going to, full stack development in that sense, I think is going to take off a lot.
There's some discussion that software as a service, as a business model, will die, right? Because it's cheaper to build your own custom thing. But it's also not that cheap, and I think you're more realistic there, that it's not somebody doing this on the side, right? Just let the agent generate it, because you're then fixing things all the time, right? So having a small team on site rather than a small team that already deals with the external vendor, right, might be a realistic approach, maybe.
On the opposite end of that thought, I interviewed with a company who does integrations with Salesforce, and they are right now having this conversation. Is our entire tool is going to be automated by clients who use our tool? But their argument is why would our customers who have other business goals, ways to make money, why would they put resources into figuring out another product like that? Their software engineers should be focused on their core business.
Right. So the Salesforce argument, or I'm from Germany, so the SAP argument, right, is pretty much this: your business is not in software, right, and you're actually much better off if you adjust your processes to our software, right? Then you get the industry best practices, but it ends up that everybody's spending so much on customizing this, right? And there's this whole industry around it, and maybe the balance shifts toward more custom software. Maybe it's not clear to me at this point, right? And then if all your custom software is slop and you get constantly attacked, right, that's probably also not a good sign. So the thing where we face this is, for example, student applications portals. In SCS, we used to have our own that was done by a small team in SCS.
One guy.
That was later. It was originally a small team and then was maintained for years by one guy. The guy is no longer with the university. We bought Slate instead, which is like the Salesforce of applications. It's a massive system. Like, they invite people to SlateConf, where they try to throw a party and convince people, and you do a lot of customization, and everybody hates Slate, right? Like, it's slightly better for administrators. Our old system was terrible, but Slate is even worse, right? And I think right now you could justify maybe keeping one guy who maintains our system, but then also you have to worry about things like security vulnerabilities, right? Maybe prompt injection attacks. Do you want to take that risk, even if it's one guy with an agent? How much are they in control, right? I think there's a question of how far you scale this.
Speaking of as a data scientist, I feel like apart from the technical tasks are being contracted by AIs, sometimes data scientists have a value to answer vague business questions. So for example, sometimes, when I was doing intern, I got asked a question like, what is the revenue headroom for our next fiscal year? So that is a quite vague business question. So I feel like more values in the future will be like how to define vague questions.
Right.
And also is that data scientists are called scientists because they are science in their daily work. So I feel like the mathematical part will become more and more valuable because that directs how are we going to answer the question and how are we going to do the experiments.
I honestly think data scientists, the science is more honest than computer scientist. So I think this, until recently at least, was the standard answer for this, right? For are data scientists going to disappear because of AutoML or now auto research and agents doing things, right? And the answer here was AutoML doesn't spend the end of data scientists. It doesn't auto-select a business problem to solve. It doesn't auto-select indicative data. It doesn't auto-align stakeholders. It doesn't provide auto-ethics in the face of potential bias. It doesn't provide auto-integration with the rest of your product, and it doesn't provide auto-marketing after the fact. I think you could argue that a bunch of these actually you could do now, at least to some degree with a skill file, right? But I think there's still some of the science part, and I think overseeing some of this, these agents make so many mistakes, and having some knowledge of how to rigorously evaluate something is still a very useful skill. Like 6 years ago, which I know is a long time in the current thing, right? But when they studied software engineers trying to do data science tasks, it shows how bad they were at evaluating things, right? They didn't do any data cleaning. They didn't really understand the separation of training data and test data. And so there was a lot of overfitting and so on. And again, you see agents doing similar mistakes now. You can fix a lot of this, I think, over time, but I think there's some value in actually understanding how research works, right, as a data scientist, and having some taste for what problems to select or some intuition of what to study. Quick tour, because I think this is actually quite interesting. I mentioned this earlier, right? So in 2016, Geoffrey Hinton stood in front of, I think, Europe's crowd in a keynote and said, we should stop training radiologists now, right? It's completely obvious that within 5 years, deep learning is going to be better than radiologists. There's an article that I quite like from late last year that talks about the state of radiology and AI these days, and I kind of just want to walk through this briefly. So the demand of radiologists has increased. Vacancy rates are at an all-time high right now in radiology. We need more radiologists than before. And if you started 10 years ago, when Hinton said, stop training radiologists right now, that was exactly the time to get into radiology. Salaries increased quite a bit in those 10 years, right? The standard salary, the average salary for a radiologist is $500,000 a year. I don't know whether you can make this as a starting salary after. I mean, starting salaries, this is probably not it, but, and they had all kinds of, so radiologists, actually AI systems in radiology are pretty good. They can do all the standard cases. They all saturated on benchmarks, essentially, years ago, right? They're in a place where software engineering is, they're 10 years ahead of us, I would argue here, right? They had the big crisis. Should we send our students into radiology, right, 10 years ago? The same thing that parents are not now kind of telling their students, maybe consider something other than computer science, right? Because what's the future? But they had all kinds of problems. It worked well on benchmarks, but it was really hard, and is to this day pretty hard to translate this into a hospital setting for several reasons. Let me go through a bunch of them. So we talked about this earlier too, like data scientists, machine learning people overfit on benchmarks, or they focus on benchmarks too much, and they saturated the benchmarks, and the benchmarks were not that realistic from what was actually needed in a hospital setting. I suspect, I think Claire has strong opinions, we see similar things in software engineering now. We see massive progress on SWE-bench and similar things, and it's not clear how representative these are of developer practice, right? I don't think we have really strong data of how great these tools are. We have lots of anecdotal evidence, right? People like them, like coding agents, but how well are they actually doing? How much are they speeding us up? How many mistakes are they doing? We have mostly benchmark data, and I would argue these benchmarks are not super representative. Claire?
Oh, I could share a dissertation about this. Historically, shared benchmarks drive scientific progress within any particular community, right? Like, this is known, but benchmarking is not interesting, and I think that that's what all these foundation model companies are doing, both from the evidence of my senses and from conversations with people who are doing benchmarking at the foundation model companies. So both benchmarks are good, and also they're possible to use them badly. And actually, I think representativeness is a problem, but I think it's actually more how they're being used than what they are at this point.
So what they found in radiology was a lot of things that we talked about. This, not all inputs are equal. We talked about this. The average benchmark had mostly easy cases, and the models struggled on all the corner cases. But you couldn't really improve the benchmark much because the corner cases were not that common. And the models, we also had this explainability thing where the doctors, especially in the beginning, really deferred to the AI. And if the AI made a mistake, the doctors made a mistake, right? And it's always in the one direction. If the AI says there's no cancer, the doctor wouldn't check, right? And I think you can probably see similar things in software engineering. If the AI says there's no security mistake, you're probably not going to check. If the review bot says there is one, you're probably going to look at it. Readings, radiology scans is only a part of a radiologist's job. They do all kinds of other things, and as they got support for reading these scans, they focused more time on other things like communicating, explaining things, right? Teaching to some degree, meetings. I don't know that they spend more time on meals, but and I think similar things in software engineering. Even if you speed up coding by, let's say, a factor of 10, you're probably not spending most of your time on coding, actually. So let's say 20% of your time is coding, and you can do 10 times more. But that also creates more work for the other things that you're doing, maybe reviewing things or fixing things, right? So even if you get a 10-time improvement in coding, how big is an improvement going to be overall? Probably not 10x, right? From what I've seen, the typical studies on productivity improvement in coding average around 30%. With the higher quality the study is, the lower the results are. Sometimes near zero or negative even. This doesn't account for progress in newer models necessarily, right? There's always a thing where you can say, well, the latest model changed everything. But it's almost certainly not 10x, because that would be really easy to show in an experiment. This is maybe a little bit more specific to radiology, but I think you can find similar things. You mentioned the accountability laundering earlier, right? In hospitals, people are really reluctant to fully automate radiology. They always want a human in the loop, partially because malpractice insurance very clearly say, we won't insure AI. We don't know how to insure AI. If it makes a systematic mistake, we may have a liability, a big claim here across so many patients that we would go bankrupt. Right? So you typically do insurance that if a human makes a mistake, you pay out and the patient gets compensated. But no insurance company wants to do this for AI models. We don't need insurance in the same way for coding agents. But I think there's still the question, if you build software that creates harms, right, who do you hold accountable? Are you laundering this all? Are you willing to do this, right? Because you can't just blame, oh, Cloud Code did this, right? Cloud Code should pay for this mistake. That's, at least right now, not going to happen. The way that one AI company in this medical space is trying to do this is they're essentially betting the company on this and self-insuring. They're telling to hospitals, if you get sued over an AI diagnosis, we will cover this. Our lawyers will do this and we will pay out if necessary. So if they have substantial problems, they might get sued and have so much damages that it kills the company. But because nobody else is willing to insure this, this is essentially the strategy that they're going for. And as far as I know, according to the article, there's one company that's doing this. Right? Everybody else insists on a human in the loop, and so we still have radiologists. Assume you've seen this, right? The cheaper a task is, the more we do of this. We've seen this in radiologies too. As radiology became cheaper, we did more of it. We actually increased demand for imaging, X-rays, and so on a lot. We do now way more X-rays and MRIs and so on for less severe things than we would have done 20 years ago. The big improvement in radiology, by the way, was not AI, but was a digitalization, that you didn't send paper scans around. That was actually a much bigger improvement 10 years earlier or 15 years earlier. And what this has ended up in is that radiology imaging became a little bit cheaper. And we're ordering way more of this, and we need more radiologists in total. Right? I think this is a hypothesis also for software engineering, for data scientists, that as it becomes cheaper to write code, maybe we go away from software as a service and write more custom code. I don't know that it's going to happen, but I think it's a reasonable, plausible hypothesis that a lot of people share in this space. I think there's other, beyond radiologists, I think there's other things that we can speculate over. I think with coding agents, we make coding much more approachable to more people. So maybe we have more product managers that actually before sketched things in Figma and now build kind of working prototypes. But then they want to get these working prototypes into production and don't understand that this is not really what you could put into production. There's a question of how close they can get with better tooling, but I think it shifts responsibilities around, right? A product manager can do more work in the requirement space to design space to maybe even coding space, but it probably won't do the entire engineering process, the entire safety analysis and everything on their own. Right, and I think more of us, more technical people, might get more into requirements, into user-facing roles, right? Because we have maybe more time and maybe do a little bit more product management. It's somewhat getting old, but I was arguing with a colleague on Twitter when it was still Twitter about the future of software engineering at that point. And he was saying that virtually everybody is or will soon be building ML applications, and I think we are at this point, right? Only few can afford dedicated software engineers to team up with or software engineering educations for themselves. It would be more inclusive to build SE into the machine learning processes so that everybody could build better. What's your thought? And are we there with agents? We just give data scientists a coding agent and they can build software better. We don't need software engineers. Do we just need more unicorns that do anything? Anyway, one way to think about this, and this is, again, another pandemic kind of thing. For some reason, I was watching way too much home renovation shows during the pandemic. I got out of this. I don't know why, in retrospect. Yep. So I think the analogy here, a nail gun is so much more efficient than a hammer, right? So if we get people better tools, they can build faster. And actually, when watching this, I was surprised how much home renovation stuff is fairly reasonable to do yourself. I mean, not that I would want to, right? But it's not as hard as maybe I would have imagined, just hammering a few things in there, building something that you could learn. But is this a good idea, right? Should we give people just more and more powerful tools? Do they know how to use those tools and how to use them responsibly? You wouldn't want to give people really powerful tools and then expect them to design a house from scratch. You would still have somebody to check the design of the house, that it doesn't fall down, that the beams are strong enough. And maybe you can use an AI for that, but also maybe you want somebody who actually understands what they're doing, right? And in the same sense, maybe you want to have a software engineer to look over your AI-generated crap, or check some of this, right? Or maybe work with a person who has specialized expertise for some of these parts, right? So just giving somebody more powerful tools doesn't mean that they know how to use them. So to me, this is more of an education problem than a research problem. And I think, and this is how I've been thinking about this course, that we need interdisciplinary teams where we understand the area. Maybe you don't need to know everything about software engineering, but you need to know how to talk to a software engineer, or at least what to ask a model for, right? to ask it for, to do this hazard analysis, for example, or to do the security review. So I think software engineering and data science skills each will have their role in the future. Maybe the role will look different. Maybe we focus on different things. I still don't think we can have unicorns, people who know everything, even with an agent. And so I still believe, even with AI agents, that this is still the right way to look at the world, right? You want to have expertise in some area, but you need to know enough about other areas that you know how to talk to people, or that you know what prompt to write to an agent, right? I think actually talking to an agent, still, you need to understand what to ask for, right? It can simulate what an experienced system architect might think about if you ask the right question, but I think you need to ask the right question. You need to know what you ask for, and maybe need to know how to read the answer. Right, so I think even if you're working with agents, this T-shaped skill is probably still useful. All right. Let me skip this and do one last breakout. Sorry. And it's the first breakout again. I want you to think through exactly the question that you did in the very first lecture about music generation. Think about one machine learning challenge, one engineering challenge in building the product, one challenge from operating and updating the product, one team or management challenge, one business challenge, and one safety and ethics challenge. If you still can find your old answer, you can look at it, but also feel free to just do it from scratch. All right, go. Talk about your answers in detail. I suspect your answers were a little bit different at the beginning of the semester. At least I hope so. And I think this is roughly where I want to end. Right, so I hope you've learned something through the semester. You probably learn a little bit more as you prepare for the midterm. I want to remind you to fill out the feedback form. And this is where I want to end. And thank you for coming and bearing through this.